Okay, the URL is jupyter.org/plat. Python fresh patch. Yesterday we have done batch and the project, starting the project. If you guys want to go to data, next week we'll have one session on that is the picking one. I've also submitted the doubts and any of the topic under for declare that what is the topic, otherwise acknowledgement. Author is Mason. Correct. So go to this website. I share the recording. Recording is direct. Yeah, I share that. Jupyter.org/. Django. Well, see, so what you have taken? You have taken Python, Django. So you have not taken front-end, right? Then I think we are done. Back-end. Django will tell you fine. I think we can start. Okay, so go to this URL. You get this thing. Okay, we have two things, right? We can use ideally. That is, we can install Python in a local system, or we can install Anaconda Navigator. Okay, Anaconda Navigator contains your Jupyter notebook. So we can install Anaconda Navigator also in our local system. What we are trying to do here is, without installing anything, we are trying to use the online notebook. Right? So you can use jupyter.org, that is the online notebook, or we can go to Google Colab. Google Colab is one more online notebook platform. Okay. So let's go to this, go below, click on Python. Okay. Click on this link, Jupyter Notebook tutorial on Binder. So Jupyter Notebook tutorial in Binder. Click on it. This will open the notebook. Under Jupyter Notebook section, you will find this link. Okay, this opens up the notebook. Go down, go slightly down. Python, that Python. Okay, click on it. No, that go up. This up, yeah. Click on this. Yeah. second option, Python. Okay. This opens up the notebook. Go to File, New Notebook, and click on Python 3. Okay. This is the notebook. The advantage of notebook is we can download this once we are done, and the next time when you want to use, again you can upload and start using it, right? And each box is presenting one execution window, so you can create the so you can write the code and then shift enter, that will execute, or you can go back to this box again and then run, that will also execute, right? The advantage here is it is more user friendly. You can go back and start editing and then again write something and execute. And ideally the problem is if you go with other tools, there once it is executed you cannot execute the same line, you have to write it down. And here it's kind of easy. Right? So Jupyter Notebook is mostly used in data science. Right? But for now we can go with Jupyter Notebook. Later when we start with functions, then we'll start using VS Code or PyCharm IDE. Right? Here you get the status. If the status is coming as not connected, the error, right? That means your notebook is disconnected, right? And then whatever code you execute, it will not work because execution will not happen. So you have to ensure that this should be trusted or connected. Okay. When we are executing, you'll see one asterisk mark here. That represents that your code is in execution. Right? If asterisk is not there, that means it got executed. Right? So you'll just see like now asterisk will come for some milliseconds. It came, right? So while executing, it will show the asterisk. So sometimes it happens that you are executing the code and this got disconnected notebook. It will be in progress, but nothing will happen. So in that case, you can go and restart your kernel. When you restart your kernel, again this notebook will try to connect to the kernel, the server, and try to set up the connection. Okay. Fine. So we know that in Python, right, there will be a concept of variables, data types. We'll quickly go through that topics again, right? So there will be a concept of variables, data types, operators, and keywords. Right? This four concept will be there in any language that we come across, right? Variables are nothing but the placeholder which can hold some data. Right? Why do we need a variable? Because until we execute the code, we don't know what kind of data will be coming, right? So we need to have some kind of placeholder based on which we can write the logic, right? So variable names in Python or in any other language always starts with alphabets. It cannot start with a number, right? But it can have a combination of number, alphabets, and underscore. We can also start the variable name with underscore. So this is a valid variable name, right? When I do underscore ABC, it's a valid variable name. Even this is a valid variable name, starting with alphabet, but combination of underscore, alphabet, and numbers. Right? But if I start something with number, then error. So ensure whenever you're creating a variable name, it should be starting with alphabet or underscore. Right? What are keywords? Keywords are nothing but the predefined word which has some meaning from the given by the language. Right? Some predefined words which comes with some definition or meaning defined by the language. Right? Something like for loop. So for is a keyword. While is a keyword. If is a keyword. In is a keyword. Else. Elif. Def. Whenever you are defining a keyword, it becomes green in color. Or in some tool, it might become orange in color. Right? So those are the keywords with some meaning, and it is not recommended to create a variable name same as a keyword. What will happen if I do this? Will I get any error? Will not get any error. What Python does, Python will create an object with this name and assign the value 19. Now next time when you're going to actually use the for loop, right? That is not going to work because for loop will point to this definition. That means you are overwriting. You have overridden the actual definition with this. Right? So ensure when you're creating the variable name, should not use a keyword. Now we have something called operators. Operators are basically used to perform some kind of operation, right? And operators will always be applicable on the operand, right? So we'll have some operand, and on that operand we can perform the operation. So there we need the operators, right? We have arithmetic operators, which are plus, minus, divide, multiplication, true division. Double slash is known as true division. Okay, and then we have power. This is a power operator and modulus. You know what is modulus? What does it do? Modulus. Remainder. Modulus always gives the remainder. Okay, so if I am doing 45, sorry, 4, 3 modulus 2, remainder will be 1. Okay, when I am dividing 3 by 2, this will give me 1.5, right? And what does the true division do? It gives only the integer part. It does not give the decimal part. So if you need only integer value, then you can go with the double slash. If you need both, then you can go with single slash. This is power. Okay. Then we have logical operator. Logical we have and, or, not. To perform the logical operation, this or this. So if this is true and the second condition is also true, then we'll do something. So that is an AND. If either of the condition is true, then we'll do something, that is OR. Right? And if you are taking the negation of the condition, so whatever the condition comes, we are taking the opposite of it, that is not. Right? Then we also have comparison operator, which contains the equal to, not equal to, okay, greater than equal to, less than equal to. Right? So these are the operators used to perform comparison. Okay, clear, right? The next part of fundamental is your data types. Now we have created a variable that can hold different types of data, right? So in order to categorize or segregate the feature, why do we need data types? So that we can define the feature that can be associated with a particular data type. So integer and string. In integer, I can have a feature of uh, taking the ratio, right? Fraction. I can have a feature of finding out the complex number and imaginary number. But the same thing, same kind of feature will not have in string, right? For characters, we can have a feature of replacing, right? Converting into lowercase, uppercase. Okay, so this kind of feature we might have. So we need data types to segregate the feature of each type of data, right? So one of the data type that we have is number. Inside number we have int and float. Then we have string, we have list, we have tuple, we have dictionary, we have set, then we have boolean, right? And we also have frozen set, right? So these are the types of data that we have, right? Now if I create a equal to 90, how do I know what is the type of this data? Ideally what happens in other languages, we go and define what type of data it is. So this is a type declaration. We declare the type, right? Why do we declare the type in other languages? Why not in Python? Because the concept behind data types in Python is completely different than what we have in other languages, right? This one thing which will be constant across any topics that we go in Python. That is, everything in Python is a class and object. Python is 100% pure object-oriented language, right? Which means the other languages, Java, C Sharp, are partial object-oriented. They are not pure object-oriented. Right? We call it as a object-oriented languages, but those are not pure. This is 100% object-oriented Python. So everything in Python is an object, right? As we have already discussed. So everything in Python is an object, so we do not need the type declaration. Second point is Python is an interpreter-based language, not a compiler-based language. Right? So in compiler-based language, there are two steps: compile and execute. So first you compile means you check the syntax, and then you start translating means you start executing. So there is a compiler and interpreter. Right? When you're compiling, since execution is not happening, right? So when you're compiling, compilers should know what is the type of the variable. If you are doing a plus b, then compiler should know whether both a and b are integer or string integer. And based on that, compiler will give you some error, right? In case of Python, since it's an interpreter-based language, there's no compiler, there's only interpreter. Everything happens in interpreter phase. Runtime, when you're running the code, then only your syntax is getting verified by the interpreter and getting translated, right? So in Python, we don't need variable declaration because it comes directly to the interpreter. By that time, interpreter also has the data. The interpreter is the one who is executing, right? So interpreter has the data, so it directly understands it. We don't need type declaration. Now when I create this, and check the type of A, this gives me class integer. If A is coming from class integer, then what is A? As per the Hooke's concept, A is the object of class integer. If A is the object of class integer, which means when I do A dot, I should see all the features that we have defined inside this class. So where this drop down is coming? We have not done anything, right? We just created E equal to 90 and we started getting this drop down. From where the drop down is coming? From class int. It is coming from class int, which means if I change this value to a string, now I should see different things. Now we are getting different things in the drop down, right? Now from where these things are coming? Class string, right? When I put a square bracket, it's a class list. Now when I do a dot, from where these things are coming? Class list, which means you go and define a class. I create an object and I can access everything that you have defined inside the class. That's how this data type has been created. Python community, the one who have developed Python, right? They have defined these 8 classes with name, int, floats, str, list, tuple, set, dict, frozen set. These are the class names that they have given. They have defined these classes, and inside the class they have defined the features, functions. And today we are calling those as a data type. We are creating the object and using it. Right? Let's create a function, add a comma b. What does this function do? This function just add two numbers. Don't worry about the syntax. We'll go through function topic later. But just to understand how things are working in Python, I've created a function which takes two numbers and we are printing after adding both the numbers, right? So when I call this function and pass 2 and 3, it gives me the output as 5. It's working. When I check what it is, it tells me that it is a function, right? Let me check the type of this. It's a class function. That means function is also coming from a class. If function is coming from a class, then what is add? If add comes from a class, then what is add? Hmm? Who can use the class? Object of that class, right? So first you have to become the object, then only you can use the class. If A is using the class, then what is, sorry, if add is using the class function, then what is add? Add is the object. Add is a function object, right? Add is a function object, right? So once we create this object, when I do add dot, I get a drop down. What's not coming? Okay. So what happens when you define a function? If there is no syntax error, then interpreter will convert the entire function into code object. Right? It will convert into a code object. Okay? And this code object is stored into some memory address. So ideally whatever code you are writing, machine does not understand that, right? So machine understands binary language. That means interpreter, translator, that will take your code, check for the syntax. If there is no error, it will convert into what machine understands, and vice versa. Right? While converting, the first step is it will convert into a code object. Right? That code object will contain all the information of your function. That means how many variables are there. So there are two variables, A and B. Right? So it defines everything. This is not a concept to learn. This you are not going to use anytime, but it's important to understand the code part, how things are designed. Because Python is again a software, right? It's a software to build another software, right? So what is the architecture of the software? How it is working, right? Right? What is this? This is the bytecode. That means the source code which we have written, it got converted into the bytecode by the interpreter. And when the bytecode will generate, when there is no error. If there is no error, no syntax error, right? If there is no syntax error, then interpreter will create the bytecode. And this bytecode goes to the machine and execute. Right? Clear, right? Now the question is, we are not able to understand this bytecode, right? Let's try to decode, let's try to disassemble this into the assembly language, right? So for that, what we have to do, let me import a library called disassembler, and then this dot this, pass the bytecode. How many are electrical background? Microprocessor. How many are from computer science? In your computer science also there was microprocessor lab, right? Right? So if I execute this, this gives me the machine level instruction. This is how everything works in the machine, right? Language is what we have for our ease. We don't want to write this kind of code, so we created a language, Python, Java, C Sharp, where we are writing the logic and then everything gets converted into this structure. This will be, no, it's not a data type, it's a function, it's a module, library. In that library, we are passing the bytecode and getting the assembly instruction. Now in this instruction, you can see there are four columns. The first two column is a line number and a description. Machine does not understand this. Machine understands only third and fourth, 01. Right? Whatever we do gets converted into. The only difference between Python versus other languages is Python is an interpreter based language, so we can see all those things because we are directly talking to interpreter. Other languages are compiler based language. So there is a compiler in between and we cannot go beyond the compiler. That's why we cannot see all this information. Right? If you guys want, try executing this. Just execute this. go below. Clear, right? So this is just a working. How does a Python work? Okay, so we have created a function. We are calling the function, and then we are checking the code, bytecode, right? And then we are disassembling, converting the bytecode into assembly instruction, right? So this part is clear, right? How does Python work? Whenever we write down a code, what happens in the interpreter, right? And everything in Python is a class and object. Now what we need to do is we need to go through each and every classes: string, integer, float, list, tuple, dictionary, set, and see whatever we were looking into the drop down, right? We need to understand what are the feature of each classes, what are there in the drop down, how to use those features, right? So that's what we'll do for next 4 to 5 sessions. Okay, that will complete your fundamentals. Once we are done with the fundamentals, then we'll start with logic building. Okay. Well, so what I'll do is I'll now upload this notebook along with the recording in Google Drive, and I'll share the Google Drive link in WhatsApp group. Right. We are going very slow for now for this week. From next week, we'll go with the topics fast. But for now, we are just trying to understand the base syntax. Right. Focus on the syntax. Focus on this concept. Right. Because this concept will be applicable when you start going through Django, Flask, data science, machine learning, wherever you go, the concept will be same. So we are just creating the base. So the learning advanced concept will be easy. Okay, fine. Fine. So tomorrow we'll start with string. Rest. Tomorrow we'll try to cover string. Okay.